All right, got the first development stream underway. Almost certainly I'm talking to myself right now, which is very fun. But who knows, I guess we'll probably put the YouTube video up as well, so that'll be cool. I am making sure that this is working. All right, nice. We can hear ourselves. We've got that running. We should probably change the stream title, actually. That'd probably be cool. Twitch TV / College. Oh boy. Cool. And we will set the title. Can I set the title? Title. How do I set the title? This is insane. There must be a way to do this. How does the title change? Our first real challenge here. Who developed this? Chat highlight setting. Mod view. Let's go to mod view. Oh boy. Edit. College. We are doing, oh, well, let's say College development stream. We Devin. Make that nice and lowercase. Now we don't need we Devin. Development stream. Cool. All right. We got that. College development stream. I think that probably worked. College development stream. Guess we can let the people know as well. Oh boy. None of this. Remind me later. Over here. If anyone is interested in watching me do an hour or so, maybe two, who knows, of development work for College, feel free to watch now. We are live on HTTPS College. Wait, twitch.tv / College. Cool. Awesome. That works, that works, that works. Very cool. All right. Well, hello everyone. We are doing some College development work. For those unfamiliar, the College Dojo is open source under active development. Look at all these commits going through. Very frequent commits. And we've got lots of things that need to be resolved. Whole bunch of things. In this stream, we're probably going to, well, maybe we'll either look at this one, because this would be a very simple thing to do. This would be a very simple thing to maybe do as a introduction to College development. We could introduce this. Or, well, I guess I don't know if there's an issue for the second one. The second one has to do with allowing Docker containers to run within a user's environment. So if we go to dojo.pwn.college and we spin up a random challenge, still don't know why this takes seconds to load. It's very sad. That's another thing we got to do. And then we click here, click here, click here. We need to support all sorts of interesting infrastructural things here. So if we launch up, let's say the workspace, launch up the workspace, blah, 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 blah. And new terminal, very large font, especially on this monitor. And we think about a challenge design. So right now, challenges are designed entirely around this challenge directory, right? We've got the flag only owned by root, or owned by root, only readable by root, cannot cat the flag. And we've got this challenge directory, which contains our only setuid binaries to root. These challenge files are the only things that can start touching a flag file. And from an infrastructure perspective, I guess we'll see, we got the chat open here. We've got it only on one screen for if anyone wants to chat about anything. But probably most of my time will be spent over here, so that'll be fine. Either way, we're developing challenges, and we are looking at the infrastructure from someone who wants to create a challenges perspective. So recently-ish, we have added an interface. Probably most people don't know that this exists because basically everyone on the dojo is a student, and students are here. I mean, most of you are here from ASU just to take classes. We are interested in expanding out the ability for other people to create dojos and challenges and basically expand our educational material. And if we look at, what is it, dojos create, let's see, nowhere, this isn't surfaced anywhere, it just happens to exist. Anyone can access this endpoint. Anyone can create their own dojo. Probably if you're at home, you might not be interested currently in creating a dojo. But if we look at this, for example, every single dojo nowadays, as of, I don't know, the last couple of months or so, is based out of a Git repo. So if we look at something like this, we've got this dojo.yml. It specifies the description for a dojo. It specifies the modules. Within the modules, we got challenges, right? We got a whole bunch of stuff. So for example, in this case, we are looking at the example dojo. We've got the hello module, the Apple challenge. And if we look at this, there's this program here. Well, guess what? It's kind of a boring, you're not going to learn anything from this challenge, type of challenge. But it just spits out the flag, right? And it's using pwn.college Python to make sure that it has a setuid Python, and the rest is good. Example dojo basically explains all of this. So currently the infrastructure is set up in a way where everything just runs out of this challenge directory. So all of the challenge specific files exist in this challenge directory. All of your persistent stuff exists out of your home hacker directory. And then, of course, we just have a whole bunch of tools that are just included here, right? We got a whole bunch of stuff that you might use for whatever it is you're doing. So something we're interested in adding from a challenges perspective is the ability to basically spin up a Docker container. So you'll see right now, right away, that the Docker command does not exist. We want, and we need to do this performantly. So I guess another thing I'll point out, just some more background before we really begin this stream, is that we have this VM command. And the VM command allows us to start up a virtual machine. How can I demonstrate what this is about to do? We don't need that. HTOP. I don't have HTOP? Oh, that's so sad. There's not really a way to show my container's memory usage, is there? Let's see here. PS command show memory, or Linux show total memory usage PS command. I don't know, maybe the PS command. Does the PS command have the ability to show memory? Let's see. So I normally run it like this. So it's memory percent. I want like megabits or megabytes or whatever. The free command, I know about that. Free, but that's, yeah, here's the issue, is it just shows the whole system. So now you know, right? The system has 252 gigs of memory. Let's say for my C group. C groups are basically how we limit you to 4 gigs of memory. I want to view how much memory do I have. Oh, well, that's cool. Let's see if that works. ls sysfs C group memory. How do I view mine? not clear how we do that. Memory, did it hallucinate this? Usage in bytes. That doesn't exist. Oh, this is very sad. Oh, and we lost the terminal. New terminal, lsal proc self C group. There's not really a way to view. Well, maybe this one. No, it says your C group path. Your C group path does not exist. Yeah, it does, but it doesn't exist. It's so confused. Okay. Maybe I'm confused. Who's confused? sysfs C group memory. lsal self C group or sysfs C group memory. Any of these even directories? I don't know what it's talking about. Memory. What about just memory usage in bytes? Let's see. Cats. Well, that doesn't look very realistic, but who knows? Let's say this number divided by 1024. That's kilobytes. Megabytes. Oh, okay. You know what this is? This is realistic. Okay. So let's do that. Get rid of that thing. So we're currently using 377 megs of memory. That sounds believable to me. Python-c print read. Wait. Python-c print open this thing. Okay. That thing, read, divided by 1024, divided by 1024. Boom. Okay, I just cannot hit Control E and it's very sad. Okay, you know what? We're going to switch to SSH. Let's do some SSH. In fact, well, yeah. SSH dojo hacker at dojo.pwn.college. Okay, and what file were we reading? Let's just copy this. Copy, paste. Somewhere we're missing parentheses. Print. It's over here, unmatched. Let's delete one. Okay, turn this into an int. Almost there. Okay, this is how many megabits, whatever, of memory that we use. Megabits. Cool. And then let's do a watch on this. How do we... Does that work? Nope. Wait, why does this not work? Man watch. Watch echo hello. Watch this thing. Oh my, I don't understand. What is happening? Nope. Okay, we are highly screwed on this one. Whatever. We will do while true, do sleep one, done. Cool. Okay, here we go. Now, if we SSH in again, and we zoom this in, and I gotta remember the top right corner is blocked by my camera. And we do the following. We're going to see that if I do VM start, we're going to see memory is jumping up very quickly, right? It's going up to 500 megs. We're using quite a bit actually for the workspace and desktop that we don't necessarily need to always be using. But we're thinking about this from a performance perspective. So we got to be careful about memory usage. And basically, we're looking to create a style of challenge that can be run from Docker containers. So if we want someone to be able to create their challenge with their own environment, it's kind of a mess. But basically, long story short, we want to be able to run Docker within a user environment. We're not totally sure that this is the correct route, but before we even know whether or not we want to do that, we kind of want to explore what it looks like to be able to get Docker running in the user environment. And it turns out that it's a little bit tricky because the user environment itself is a Docker container. We want to run a Docker container within the Docker container, and privileges make this kind of tricky. So we'll see, for example, if I user add -m test. Oh, no. Either way, we're going to need a privileged container. Let's see here. Privileged container, privileged container, privileged container. What is the topic today? The topic today is development of pwn.college. And specifically, this is kind of, we have a simple goal right now. And maybe we'll abandon it in favor of a simpler goal for our first stream. But this is what I was working on before the stream, so this is what I'm probably going to do anyways, because kind of get to get useful things done during these streams. They're just kind of a little bit of for fun here. We are working on getting a Docker container running inside of a challenge container. So if we do practice instead, okay, that's what we need. Okay, we'll reconnect. Cool. In fact, I'm going to bring this over here. Let's get rid of that. And let's shrink this down there. Okay, cool. So what we're going to do is we're going to see if we can get Docker running. So obviously, as a first step, inside of this user container, Docker command not found. It's because Docker's not installed in here. So that's clearly going to be the first issue. But we have a number of issues, as we're going to see here in a second. Okay, if I want to install Docker, I believe I have it in my history. But actually, before we do that, I want to create a user named test-m, gives me their home directory. And then I want to switch over to the test user. The reason for this is I want to not worry about my home directory. So my home directory as the hacker user is 1 GB. I'm about to fill that up. I already know this because I've previously done a little bit of work on this. This is something we need to do. So if we want to install rootless Docker, and rootless Docker basically allows us to run Docker without being the root user, which is going to be effectively necessary for this because it's not just the root user, it's a bunch of capabilities surrounding the root user. We need to, I just know we need to run rootless Docker. So we need to install this. And I have internet access inside of my challenge environment. That's why I can start doing stuff like this. Very useful. Sudo su test cd there bash. Okay, and now let's go ahead and install Docker. So it's very nice to kind of just do development in this container because this container currently has all of the restrictions of a user container. So if we can get it to work here, we can get it to work in the general sense. So we are trying to get Docker running in this user container. Now, if I add systemd, not, who cares? Okay, we'll just do whatever these exports are that it's mentioning. We'll run this, and we'll run this. Okay, so here's the issue. The issue is when I do this, Docker does not run. It's very sad. We'll see error, failed to start the child, fork exec, proc self exe, operation not permitted. I can't run Docker in the user container. And And it's very sad that I can't. Okay, I'm going to actually switch over to doing local development instead of just doing it on the live instance, so that I can start modifying stuff. In fact, actually, before I do that, though, I will show you why this fails. So if we strace this, and we want to get rid of some of these syscalls. So let's get rid of nanosleep. How do I do this? Oh, there we go. That got rid of nanosleep, I think. Yeah, I don't see it. Let's get rid of clock get time. That's probably good enough, actually. So we can see that right here is where it says that it failed to exec. We can see, where can we see the actual failure? Somewhere we got an actual syscall fail. That doesn't really matter. This right here, this is a syscall that we don't want failing. This says operation not permitted. And this is the reason right here, at least this is the first reason why we cannot run Docker inside of our user container. It's because this clone system call, we get operation not permitted. And the reason we get operation not permitted is because Docker runs with a seccomp filter. And that seccomp filter basically says only certain system calls are allowed. And clone with these arguments is blocked by the seccomp filter. So this says clone underscore new namespace, clone new user, sigchild. There's kind of a lot going on here, but this is the basic mechanism by which a Docker container works. It's these namespace things. And the way that you get your new namespace things is you do the clone system call. And so this is setting up a new network namespace, or no, a new, yeah, is it new network? New NS. We'd have to look into that. I think that's network user, and I don't know, this does something. It's another flag that does something. I don't know, something to do with sig children. Who knows? But this system call is being blocked, and this is the issue. So if you look here at dojo.pwn.college, or at, I should say, the repo, you'll see I just added in this commit earlier today, which just basically says that the clone system call is allowed. No matter what. There's some danger to that, but let's just roll with the danger anyways. This is not, however, in the production version of pwn.college right now, so that is not there. So we're just going to switch over to a local dev environment. So let's do gets pull, already up to date. Let's see, can I zoom in? 2, 3. We'll do that. Cool. Clear. That we said get pull already succeeded. Get log. Oh, we're on the wrong. Get checkout master. Get pull. Get log. Okay, now we have this YOLO commit. And if we rebuild our workspace, rebuild the container, we are going to see that we're going to have a local version of all of our pwn.college dojo stuff just running. And this is now going to be configured with our change of the clone system call. So is the system running? The system is now running, I think. Registry, that shouldn't be there. Git log. Why is there, I don't think that should be running, but we'll look into it here in a second. If we look at our seccomp filter, we look for clone. Okay, clone is here. And now if we go through and repeat our steps, so let's actually first, let's go to our locally running version of the dojo. You can see here, it looks just like the dojo, except guess what? There's no dojos in here, which is our first issue. So let's start by, for our dev environment, setting up a dojo. Create. We will actually go ahead and take this. And deploy key, hopefully we don't need to do that. Really don't think it should need the deploy key for a public repo. Does it really, or is that just a bug? Is there any issue with clicking on this on stream? I don't think so. Add deploy key. Key. Local dev. Add key. Use GitHub Mobile. Well, I guess we're showing a two-factor key. That's not necessarily what we want to be doing. But hopefully no one is currently in the process of hacking my GitHub. Cool. All right, local dev key is in. And create. Okay, we need another thing on the to-do list is to make it so we don't need to do that for a public repo. That should not need to happen. But in fact, let's go ahead and create an issue. Local dev, well, let's just say public git repo, GitHub repo should not need deploy key. Cool. So we can deal with that later. But now we've got our example dojo. We've got our hello module. We've got our Apple challenge. And if we start this up with practice mode, great. Now we're in. Okay, let's see here. Do you have a video where you talk about binary exploitation roadmap? I don't think so. Do you trust Docker so much in this environment that nobody can break out of the container in the dojo? Yes, no one is supposed to be able to break out of the Docker container. That's our theoretical security model. We already know that technically there's some things we need to improve with the security on that. But yeah, if someone can break out of their user container, so like right now, I'm in this user container, right? Like I'm in this environment. If you could escape to the host, we would be very happy to hear about how you're doing that and very sad to know that that is possible. But we would look into fixing that because no, yeah, we trust Docker so much in this environment that nobody can break out of the container of the dojo. That is like, yeah, we've got to run on that model. If you have ever installed Docker inside a Docker container, having several problems when doing so. I need to do this because I have to run my script inside a Docker container. And this script uses Docker login. Yeah, well, guess what? That's what we're working on here. How you do that probably depends on exactly your problem statement. So for example, some things for you to Google. Docker in Docker versus Docker by Docker. Read stuff about this terminology. There's a good chance that for your use case, what you can do is just mount the Docker socket in. Do you have a documentation how you secure your user container? I mean, not really. Let's see here. GitHub, .college, dojo. I can show you where all of our Docker stuff happens. API v1 Docker. This right here is where all of the user container gets created here. So you'll see right here, grab an image, entry point, username, whatever. This is all of our networking stuff. Got our mounts. So this is how the home hacker mount ends up in there. Yeah, so this is everything related to that. We don't really document how we secure it. I mean, the simple answer is that if you just start a Docker container, in theory, no one should be able to escape it, right? If you just are inside of an unprivileged Docker container, you shouldn't be able to escape it. Unfortunately, we're not just straight up an unprivileged Docker container. Fortunately, we modify the default seccomp quite a bit. Well, not quite a bit yet, but we added to the seccomp filter, we added this unshare system call, we have added clone 3. And as of today, we have added clone. In theory, this should all only allow namespace stuff and namespace stuff for not escaping the namespace, as far as I know, but who knows, that makes it a little sketchier. But we don't necessarily document it. It's just that's the default assumption, is that you can't escape. Okay, let's go ahead though. Got this running. Let's go ahead and practice the Apple challenge. I don't think I have an SSH key set up for this environment, but fortunately, since I'm doing local dev, I can just do dojo enter 1. And guess what? I am now in this challenge environment. Who am I? Right, I'm the hacker user. Got my persistent home directory. Got the flag. Well, got the flag. If I do challenge Apple, well, it spits out the flag too. Cool. It's a very boring challenge. It's just a example challenge, but in theory now, our seccomp filter that we're running with in this environment, this local dev environment, has added the clone system call. So the issue we were facing before, where this strace thing was failing, this guy, this, hopefully we're going to see when we run through these same steps that's no longer failing. And I'm actually going to throw this over here so that I can continue to see the chat. Cool. We'll make it slightly bigger. Cool. Okay. Let's go ahead and, well, maybe we should like, I don't know, maybe we should have some sort of dev script. New file. New file. Well, new file. Who knows? Well, no, I don't really want, I just want like an untitled file. Yeah, new untitled file. Okay, we need to user add. Okay. And then we also did this. So we're just documenting everything we do in our process of getting Docker running in Docker. Obviously, at the end, when we build out the infrastructure for all of this, we're going to need to clean this all up, right? We're not going to have users like typing these million commands every once in a while, or like whenever they're doing it. But this is just kind of our experiment. We're testing things, seeing where things fail, understanding the system better. And then sudo su test. How do I get it to just run bash? What? I don't know. Doesn't matter. Okay. And then curl. Then we did this. Okay. So this is how we install rootless Docker. Cool, cool, cool. Okay. Let's go ahead and do these things. Oh boy. I only want this. This. Don't ask me this. Of course I want my stuff pasted in. Okay. Why do you think all of the CTF challenges are heading towards Docker as a running environment? It basically, Docker is just like, wait, what's happening here? Why are we not? What's happening? Do I not have internet in here? Ping google.com. Okay, I think I know what's going on here. One more thing we got to do. We got to give ourselves internet. And it's kind of insane how we give ourselves internet here. Another thing we should do for our development environment is modify this. Turns out that we give internet by awarding the internet award. That's simple. Okay, and then we got to restart our challenge. Okay. Dojo enter 1. Ping google.com. Now I got internet. Cool. Curl. Let's run these commands. Copy, paste. Cool. So there's a question. Why do you think all of the CTF challenges are heading towards Docker as a running environment? Docker is just nice because it's like the self-contained, like predictable environment. If you think about like a CTF challenge kind of is just like a single program, right? Like in this case of this, it's just the Apple binary or whatever, right? Just the Apple program, and kind of like a CTF challenge is just the program. But that's not really true. The CTF challenge is the program and its environment. And Docker lets you kind of just package an environment. And it's basically that simple. And it's way more lightweight than a VM. So for example, you can have all your challenges in VMs, but then you got to like wait for VMs to start up. And it's very lightweight. I would encourage you to just like look at using Docker more to really understand why it's so useful. But it just solves problems is the simple answer. Oops, that is not what I want. Sudo su test bash. Okay, install. Oh, I'm missing. What? Why did I not have this issue before? Interesting. Apt install IP tables. IP tables. I don't understand why I needed the IP tables here, but not there, but we're going to ignore that. Sudo su test bash. Okay, now let's go ahead and install Docker. Okay. Docker installed. Let's go ahead and grab all of these exports. Not sure if I need them or not, but who cares? It's mentioning them. Let's use them. Okay. And we failed. Oh, that's so sad. Let's see here. What happened now? strace-f. What was our strace before? strace-f. This thing. Where did we go wrong? In these epoll, I don't know what these epoll controls are. Someone's failing still. Who's still failing? Right, all this right here. Okay, this is sad. So this is a new problem. This is further than I got before. I know about some of these things, but I don't know exactly why this fails. So let's just go ahead and read up on this error message. Let's just copy literally the whole thing. And see what kinds of things people talk about. Solution is that using the source code, write to UID map failed. Now, why did writing to the UID map fail? This is kind of what we're doing here. It's possible. All in, yes. So it's basically we're trying to do Docker rootless inside of Docker rootless. Because basically we don't want people saying, well, yeah, you can run Docker rootless inside of a Docker container. It's just that Docker container needs to be a privileged Docker container. Because guess what? We can't make the user containers privileged Docker containers. We can add some privileges to them, but depends on what privileges we're talking about. We can't just do a blanket -- privileged. Otherwise, users could escape their Docker container. We can't have that. No, that's not our error. Well, part of this message, it's not very generic. I don't know about this 494. Let's see. Still need dash dash privilege. Yeah, this is the issue. We can't have that though. Someone's got to have figured out what we can do about this. And if not, well, guess what? We're gonna have to go down a different route for what we want. There is Docker and UML in Docker. What is UML? I don't know what UML is. Which only requires, but quite slow. What is this? I don't know what UML is. Sounds like they're like emulating everything. An image for running a Dockerd inside a user mode Linux kernel. It's possible to run and build Docker images without forwarding. Starts a user mode Linux kernel. A Dockerd inside. We don't want to start up a new kernel. Probably. I managed to get a Docker rootless type image working. Okay. It still needs privilege. So this is no good. We can't run it privileged. You can actually get the Docker daemon to launch with unconfined AppArmor. Okay, so this means modify the seccomp filter. Who knows what syscalls need to be allowed, but we can do this. So if anyone says unconfined, that's cool. Maybe we have to make sure that there's not weird syscalls they need, and just mounting this thing. Well, that might be scary. I don't know what this is. That looks like something we might not want to be mounting into user containers. Still needs the unmasked proc mounts to actually create containers. I've tried that. But this is 2019. A lot has happened in the rootless world since 2019. And has no one done this before? Docker rootless inside Docker rootless. Inside another Docker container. What is this? To run rootless Docker inside rootful Docker. Well, we can't do rootful Docker. Required for disabling and mount mask. So this, I think part of the issue here, if we look at mounts, we've got a lot of our stuff is mounted read-only, and I think I've hit this problem in the past where we're not really thrilled about that. But this one's not read-only, or is it? Did you have to allow specific privileges to seccomp to be able to run challenges for exploitation? So for heap exploitation, no. Kernel exploitation, we just start a VM for kernel exploitation. There's really no getting around that. In order to have a kernel challenge, you need like your own kernel, because we can't have users like attacking the host kernel, which the way Docker works is everyone just shares the kernel. We can't put vulnerable kernel stuff in there where you can like do arbitrary code in the kernel. That's just dangerous and not good, obviously. Can't have people bringing down the host. So there's no getting around that for a kernel challenge. You have to be able to start up a VM. So we didn't need to do any seccomp stuff for that, because we just start up we've just started up a VM. But there's overhead to that. So what is the reason to want a rootless Docker inside of a rootless Docker? Yeah, so basically the reason that that's my search term is I'm worried. So the outer one isn't a rootless container. So we're going off of the user container. So right now I'm in a user container. This user container isn't a rootless container. From the host perspective, root is actually running this container. But I'm worried that, like with search terms, basically everyone's going to say just use dash dash privileged, and as soon as we can't run these user containers dash dash privileged. But then the second part of that question is, why do we want to run maybe Docker inside of any kind, or rootless Docker inside of any kind of Docker? I just already know that we can't run Docker in Docker. That's just, it's going to have to be a rootless Docker on the inside, just because there's no way the security model is going to allow for anything else. And we want to be able to run Docker inside of Docker just in the general sense, because we want people to be able to create challenges that use Docker. So we're currently exploring a challenge style that is kind of like these worm challenges, where you could imagine that we're like running 100 Docker containers are running here. Like when you enter your environment, there's just like 100 containers running, and you're gonna need to like network your way through a bunch of containers. And basically containers are a good way of having these isolated environments. And we want to use containers because the overhead associated with a container is significantly smaller than the overhead associated with the overhead associated with a container is much smaller than the overhead associated with a VM. So we don't really want to rely on VMs like we do for kernel challenges for this, because we don't need like a kernel for this. This is still very exploratory, so we might decide in the end that, you know what, whatever, we just do a VM. But basically the current challenge is seeing is what the current state of rootless containers is, and if we can run Docker in Docker under our security model. Or if basically, it seems like the world is moving in a direction where this is going to be possible eventually, but it might not currently be possible yet. It might not be there yet. And the reason that I say that the world seems to be moving in this direction is because of user namespaces. And user namespaces kind of seem to imply that the world's moving towards arbitrary nested containers in a secure way. Yeah, but these people say privileged. Now, so basically there's two parts of privileged. There's one part which is the seccomp filter, and the seccomp filter, we can mess with the seccomp filter, and there's certain things that we can add to the seccomp filter that's not there by default in Docker. So for example, the unshare system call, we can just add to the seccomp filter, because I don't think you can escape your container using an unshare system call. There's some sketchiness to the unshare system call, which is that it gets you at namespaces, and namespaces have been a vulnerable area of the kernel in the past. But I'm confident in adding unshare. And eventually it will be safe. Eventually Docker will probably allow unshare by default. It's just not there yet. But then there's the other side, which is capabilities. And capabilities, we can't just start granting random capabilities. Basically, privilege is going to add stuff like capsys admin, like Linux capabilities. If we look at something like capsys admin, which is basically what a lot of things, it's kind of like the default capability. It does like a lot of stuff. You can basically get back to the host. Like you can break out of your container. Or like you can imagine like capsys reboot. Capsys boot, right? Like obviously we can't grant this to users because otherwise they could like reboot our host machine. That would be not good. Or capsys module, then users could start loading kernel modules into our kernel. Like we can't just give arbitrary capabilities to these user containers. We are in general, for our purposes, more lax on our seccomp filter. Yeah. Okay. So it doesn't seem like people are thrilled about this. How to run like the article. If anyone's talking about this, they have to be talking about it like in the last year or two, because this space is like rapidly moving in the kernel for being able to do stuff like this. That's fine. This, I'm pretty sure everyone's just going to be running a privileged container is the issue. But I don't know like the actual limitation here. Like I don't know what it is that makes it so that our whatever syscall here is failing, our write syscall. This. I don't know if this is like I just need to allow more things or what is causing this to fail. Actually, let's read up on this, the UID map. So this is how we can do UID mapping. I know some amount of stuff around this stuff. Let's just read up on it. User namespace created starts out without a mapping. User IDs. Expose the mappings for user and group IDs inside of the user namespace. View. User ID map file. User ID. So it's basically, it's doing a user ID mapping. It's basically like, for example, you might be user ID 0 inside of a container, but really that corresponds to user 1000 outside of the container. So that's how rootless containers work. So I can be user ID 1000 and I can start up a container and be root inside of it and be user ID 0 inside of it that corresponds to 1000. And the UID map is one of the things that makes that happen. Let's see, qualification. Different namespaces will potentially see different values when reading. So yeah, this is also like a crazy file. It changes depending on who's looking at it. Start the range. Yeah, so like if I look at map.proc self UID map, what does this mean? It says something like this. No consistency. Looking at the from shell shows this. This tells us that the range starting at user ID 0 maps to range starting at 0 over here, and that range is this big. Length range is the large. Yeah. Okay, so this just means everything's like the map. There's no change in UIDs. Whereas what kind of thing were we trying to write? Let's get rid of this also. So let's stop seeing it. Cool. What were we trying to write? This. And we're trying to write this right here. And actually, this looks just like, I've never been able to do this before. Let's go ahead and look at this though. So it's trying to do, okay, wait, why can I not paste? Control Y, there we go. It's trying to do this writing to the UID mapping. So what this is saying is that user ID 1001 on the outside. So who am I right now? I'm user ID 1001. 1001 on the inside. So inside the container is going to be 0. So basically it's saying, hey, I'm the test user, but inside the container, the test user is really root user, and it's one of them. And then there's this line right here, which is saying that on the inside of the container, starting at 1 maps to 16,500, whatever, this number on the outside. So this is just creating a big range of, is giving us room to have other users inside of our container. But I've always had an issue when I do this about, I've never been able to write 2 lines to this file. I've only ever been able to write 1 line to this file. So this might have something to do with it. Don't know why, because basically, if you think about it like permission wise, why would user 1001 be able to start saying what these other users are? Like, it doesn't make sense. Like, how can 1001 basically decide, well, I guess this is on the outside of the container, and no one on the outside of the container is these user IDs. How does it know that? How does it know no one on the outside is these? Something doesn't make sense. And what was our error? Maybe the actual error says something. Like, no, it's just -1. Eperm operation not permitted. Okay, so this says above fails with einval. Writes that violate the above rules, what eperm. Okay, so this means we're violating one of these rules because this is all einval. Writes that violate the above rules fail with the error einval. Oh, but we're all okay, so we're breaking one of these rules to get an eperm. Okay, what rule do we think we're writing? The writing process must have the cap set UID capability in the user namespace of the process PID. Probably it does because, okay, so we're talking about PID 482. This is going to be one of the very first things that happens after that clone system call. So somewhere, this is starting up a process. UID. So somewhere up here we did our clone. In fact, let's just go ahead. Can we grab this whole trace? Well, maybe not. Let's run it all again. Oops, a trace. Okay, so somewhere, wait, what happened here? Someone calls clone. This is creating our, nope, that's not our clone, it's creating namespaces because there's no namespace flags. This one here is, well, this does clone VM also. Clone VM, clone FS, clone files. Okay, this doesn't look, no, this is not doing, that's not creating our namespace. Nope. 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 Namespace. Here we go. This is the clone that sets up the namespace. And then, so the result of that, 528, so 535. So our PID, our very first PID in this new namespace is 535. So PID number 535 is our root PID in our namespace. 535, here we go. Look at this. We're doing a whole bunch of stuff. So right away, we unshare to create a new network namespace. Okay. Do a whole bunch of stuff. We start up ourselves in this namespace. Slurp, Docker. Probably this is how we start up ourselves again, but in the namespace, start from the entry point, pass a bunch of flags. Probably a reason you would do this. Open up, oh wait, 535. Okay, wait, but who did the clone syscall? Was it 528? Probably 528. There's so many files that get used for this stuff. It's like insane. Okay, who did clone? Namespace. This. Okay, so 528, PID 528 starts up a namespace that ends up being PID 535. That's our new namespace. It's going to be the beginning of our namespace. And then 528 does more configuration. So 528 already did a bunch of configuration stuff before it even decided to spin off this new namespace. But it looks like it's not done doing configuration, which makes sense. It needs to set up some other things. So 528 opens up Etsy password. So this is how it knows that, for example, it wants to map like 1000. Well, I don't know. It probably has some cool reason for opening Etsy password. Schedule affinity. Okay, this is, I have no idea what this syscall is, but it's setting up its schedule affinity. Docker does a lot of things. So this probably doing default C group stuff to limit what process. Who knows? I'm just making stuff up. 528 keeps reading. Okay, this right here. Get su. This doesn't exist. So it's looking for this program here. Doesn't exist here. Doesn't exist here. Doesn't exist here. Does it exist anywhere? Got a lot of unfinished. Really wish, I mean, there's ways to view everything without this unfinished stuff. Eventually, who's doing all this stuff? Oh, we're on 528 looking for this program. Look, see, it's even looking through user game. It's just reading through path. 535 is doing a bunch of stuff, though. That's why it's messing with us. Can 528 find the get sub IDs program? Open at Etsy. Wait, it seems like it did. No. Get sub IDs. Open at, but now it's doing an open. It's not just looking for it, it's actually opening. And it returns it. So I guess it's going to do it itself. What is this program? Get sub IDs program. What is the get sub IDs program? Because I've heard of sub ID stuff, but I didn't know why do you need a program for this. Get the subordinate ID ranges for a user. I have no idea why it wants to use this program. Take his word for it, though. For some reason, it wants to use that. Hold on. I start up cat Etsy sub UID. Interesting. Oh, dojo, enter 1. Cat Etsy sub UID. So it looks like whatever this sub UID stuff is, Hacker has a whole bunch allocated to it, and then Test also does. And this makes sense. So Test is using its sub IDs, right? See this? This mapping right here. So this is probably why it should be okay for this test user to go ahead and use this ID map. Okay, so I didn't know about this in the past. This is why it thinks it can do 2 lines of this, that it can allocate for itself and say that its user ID is 0. This is totally fine because it's basically saying, hey, I'm going to be 0 inside this namespace thing. I already have full control of this namespace thing. I'm declaring myself 0. But it's also deciding what these mean. Or what 1 means, what 2 means, what 3 means, up to this number, basically. And it's using its sub range. Okay, so I guess the outer container has declared somehow that this user ID 1001 from the host kind of, or at least where this is the host, gets to decide what to do with these IDs. So somehow, even though I'm user 1001, basically, even though I'm user ID 1001, I also have control over this whole range of IDs as well. Like this, and then the length starting here, and then length here. So I guess I have control over that ID range. Probably. I'm guessing that's what this Etsy sub UID thing does. Like, let's actually read. Sub UID Linux. Sub UID authorizes a user ID to map ranges of user IDs from its namespace into child namespaces. Delegation of the subordinate UIDs can be configured via the sub ID field in this thing. Only one value can be set as the delegation source. Setting this field to files configures the delegation of UIDs to Etsy sub UID. Setting any other value treats the delegation as a plugin following with the name. Okay. Note the user add will only create entries in Etsy sub UID if sub ID delegation is managed via sub ID file. Okay, I don't know. I truly don't understand why this subsystem of Linux would be managed by like an Etsy file rather than like a proc file or a sys file or something. Seems very strange because this Etsy, as far as I know, is not like backed by like kernel interfaces. It's just, I don't understand how this is like a secure spot to be putting stuff. Each line arrange. This is specified with 3 fields. I don't know how this is secure. I mean, other than I guess that you have to be root to write to this thing. I guess it's the same way that like Etsy shadow is secure. I don't know. Seems strange, but we will roll with it. Okay, so how can we fail? Well, hold on. Wait, what else were we looking at? We got mini buffer. We've got all of this stuff. Same thing for groups. So again, it's looking for, I guess it wants to create a new UID map. So I guess it's defaulting to using a program, but if it can't use the program, it just does it itself. It just does this Etsy stuff. I don't know why it wants to use a program so bad versus just implement its behavior itself, because it should just be like reading a couple of lines from a file, but who knows? Maybe this is more portable or something. Okay. Look at this, like 528, it's configuring stuff, but it's just spinning off more threads. It's not done yet. It just wants to keep doing stuff. Why? 526. It's like, at some point, basically setting up this stuff is just like a handful of syscalls, and then like a lot of extra stuff on top. But the core of the problem is probably just like 4 or 5 syscalls to get what we want. But some of this stuff is very finicky, especially once you have user namespaces. It's like, I didn't know that this is how 2 lines worked. I'd heard of sub IDs, but I guess it makes sense that this is. But then it doesn't make sense. So someone's checking that write system call, though, when we write both lines and deciding that this is insecure. Is the kernel actually checking that Etsy file to decide if, like, that doesn't make sense. Why would the kernel be looking at an Etsy file? That would be insane. Fluid debug. Look at all these things it wants to look at. Okay, where did my error go? Somewhere in here. You gotta be close. Like, there can't be this much stuff. I mean, I know a lot of this is like resuming syscalls over and over. We're starting up a process here. Oh no, this is just reading in lib, this, whatever. Okay, where did my write fail? Right. So this is PID 536. Who is PID 536? Did 535 start 536? Are we in our namespace right now? So somewhere we're gonna get equals 536. Who started 536? This person started 536. Did they? Maybe not. Maybe wait for doesn't work like that. Clone 528 started 536. Okay, so 528 also starts 536. That makes sense. Well, no, it doesn't. But this, so let's say 535 is my namespace root. Whatever. I don't know. I don't know the proper terminology for this. I just know this is like PID1 in the namespace. If it had a PID namespace attached to it. I don't think it does, but is our owner of the namespace. Is my namespace, we'll say namespace owner. Clone, because the first process in the namespace, that's the namespace owner. It owns the namespace. Okay. So then we look at that write system call. So 536, so we're outside of the namespace. We're not doing this from the inside, we're doing this from the outside. And we're saying, at least I think, unless it sent over, okay, hold on. Who came up with 5? Open at 5. Oh, but what is open at? Open at relative to 3. See, now we got to figure out what 3 is. They might have shipped some file descriptors across. We might have shipped a file descriptor from inside the namespace. Oh boy, let's see here. Who is 3? So this is 5. Someone's going to be 3. Who is 3? Well, let's reverse search for equals 3. Hold on, that doesn't work. I don't know how to effectively search for this. Nope, that's not going to be it either. Equals -1. No, wait, what was my thing? 5, 5, 3, 5. 5, 3, 5. Look at this stuff that it opens. Transparent, huge page. Why does it need to configure this stuff? Or why does it need to consider this stuff? Like, this is insane. We don't need to be looking at this stuff. This is like some crazy edge case that doesn't pertain to me. I'm sure of it. But we write software generically and it does a whole bunch of stuff. So here we are. Okay, so 528. Read all of this. Wait, 5.3. What is 535 reading? What are you reading, 535? Read unfinished. Open at equals 4. What did we try to open? Oh, this. So yeah, I guess we read that H page PMD size is this large number. Why? Don't know. 535, 535, 535. Okay, where is my write that failed? I lost track of everything. Here. Okay. So we're writing to 5, which is opened at 3, UID map. So this is going to be a proc file. It's going to be like a proc something PID probably. Probably we didn't ship file descriptors. Let's see. 3 equals 3 equals 3 equals 3. Did it like do this years ago? Are these syscalls far apart? Look at this. We're connecting to var run nscd socket. Doesn't exist. What is nscd socket? nscd socket. What are these insane things? Like, what is this stuff? What is this? Name service cache daemon. Like, this is crazy. So much stuff it does that like I can't even do because it doesn't exist. Okay, here's 3 right here. Proc 535. So we open up proc 535, which is ourself, right? We didn't start a new PID namespace. It was still proc 535. 536 did this actually. Well, hold on. 536 did this. It was yesterday. 535. Okay, but who opened this? Because this is the wrong PID. Proc file systems. Okay, hold on. Was it 536? 535. Hold on, here's what we can do. We're going to cat temp test grep 535. Less. Right. Well, wait, what happened here? Oh, well, I guess we're not totally just capturing 535. Here. Proc 535. Where did this fail? Why do we not see the fail here? Am I like super confused? Who did the right system call that failed? Was it not 535? The right system call that failed. Less. Right. 535, right. Oh, 536 does it and fails. Okay, it's 536 that does it. All right, all right, all right, all right, all right. So 528 starts at 535, which is the namespace, and then 528 also starts at 536. 536 is some helper process for configuring stuff, question mark. Okay, so 536 does the write. Okay, this is important. So we're doing the write outside of the namespace. Okay, let's read our rules. What are our rules? Okay, the writing process must have the cap setUID capability in the user namespace of the process PID. I don't know if that's true. That sounds pretty sketchy because we're outside of the namespace. So how could I have that capability? This, we're going to say rule 1 is questionable. That doesn't sound like that would have worked. The writing process must either be in the user, wait, all of the following. Yeah, all of the following. The writing process must either be in the user namespace of the process PID or be in the parent user namespace of the process PID. So we are in the parent. We are in the parent. Rule 2, we are in the parent. That's cool. The mapped user ID, group IDs, must in turn have a mapping in the parent user ID. Okay, so we're writing to this. The mapped user IDs, group IDs, must in turn have a mapping. In what is like? So this isn't like technically defined. What does it mean to have a mapping? We'll say 3 question mark. If updating proc PID UID map to create a mapping that maps UID 0 in the parent namespace, then one of the following must be true. We're mapping in 0 of the parent namespace. So we're not. We're doing 0 in the child namespace, not the parent. But let's see what it wants, just so we know. If writing process is in the parent user namespace, then it must have the cap set fcap capability in the user namespace. If the writing process is in the child user namespace, then the process that created the user namespace must have the... Okay, what? If the writing process is in the parent, it has to have this. Otherwise, the process that created the user namespace... Okay, whatever. It doesn't apply to us anyways. This is because of a bug. There's some crazy bug. This is the capability that allows you to create file granting capabilities. And there's a security bug where because it's the same file system, you could do like capability escalation. Because you could mess with the file. And if you can mess with the file, then you can re-grant yourself capability. It's like a nightmare. It's a kind of complicated. It has to do with file capabilities or capabilities being granted by files, and the fact that you can do this, and like we need to make sure that like, hey, if you're going to have 0, basically if you have 0, that means you're about to be able to in this namespace have this with it's a nightmare. It's this user namespace stuff gets really complicated really fast. Okay. So yeah, this describes the bug. So it says you could create a new user namespace with the identity mapping, i.e. 0 in the new user namespace maps to UID 0 in the parent namespace, so that UID 0 in both namespaces is equivalent to the same root user ID. Since the child process has the cap set fcap capability, it could create a binary with namespaced file capabilities that would then be effective in the parent user namespace because the root user IDs are the same in the 2 namespaces. And what this means is basically you could make a file that can grant capabilities in the outer namespace, and basically you can start granting yourself capabilities. So all of these rules within this of what you're allowed to write to this have to do with the security model and making sure we don't break the security model. So this is like an edge case. Turns out it's kind of an issue that used to not be a rule. Now it's a rule because it's a problem. And it's been fixed by adding this rule. One of the following 2 cases applies. Either the writing process... Okay, so this is an either or. Either the writing process has the cap set UID, cap set group ID capability in the parent namespace. Writing process has cap set UID capability in the parent user namespace. For the restrictions apply, the process can make mapping. So this means you can change your user. Okay, so either the writing process has cap set UID in the parent user namespace. So we probably don't, because we're the test user, we're not root. I think probably, we can check here, cap sh print. No, I don't want this. Grep set UID. Yeah. I think this is all of the capabilities I have. So if I grep for sysadmin or cap sysadmin, we'll just search for admin. Cap net admin, we have, wait, that doesn't make sense. Bounding set. Oh, I'm not in my container. Okay, cap sh dash dash print. Grep. Which capability? Set UID. Yep, makes sense. So root inside of here can have cap set UID. In fact, if I do sudo su cap sh dash dash print. So now we have our currents, right? This is, so now we're the root user. These are our capabilities. Set UID, right? We have the ability as the root user to change our user ID. That makes sense, right? Root's got to be able to change its user ID. Well, guess what? It also needs to be able to change its user ID within a Docker container. So this is chill. But for example, sys or cap sysadmin, not in here. Or if I just search for admin, yeah, we don't even have like cap net admin, for example, because you don't have arbitrary control over your networking here. You can grant this stuff to yourself with the user namespace stuff, but then only in the context of that user namespace. But moral of the story is we don't have that. But we do, in theory, we could have cap set UID. It's just we're running as a test user. So the test user, so if I do sudo su test, and I do cap sh dash dash print, and I grep for cap set UID, we're going to see it's in the bounding set, but it's not in the current set, which means it's theoretically possible to gain this, for example, with sudo and stuff, right, that allows you to go back up the privileges. But we currently do not have it. So test user, who is the person doing this? Because 536 is the person writing, and 536, I'm pretty sure is the test user. It's got to be because we're doing rootless containers. It does not have this. Either the writing process has, so it doesn't have this, or otherwise all of the following must apply. The data written to UID map, GID map, must consist of a single line that maps the writing process's effective user ID, group ID, in the parent user namespace to a user ID, group ID, in the user namespace. I don't think this is true, right? It's not, we already know it's not a single line. The writing process must have the same effective user ID as the process that created the user namespace. This is true, right? The 536 and 535 should be the same effective user ID. That shouldn't have changed. In the case of group ID, so this is not us, use of the set groups system call must first be denied by writing deny to this thing. So this is how we start doing groups. Groups are a whole other thing. Otherwise, we get eperm. So this is, I'm pretty sure we're breaking this first rule, or this rule right here. But we could have this. We can make ourselves have this, but we don't. Or otherwise, all of the following restrictions apply. Data written to the UID map must consist of a single line that maps the writing process's effective user ID, group ID, in the parent user namespace to a user ID in the user. So this is no good. How? But then what's the whole point of the subordinate ID stuff? I feel like this doesn't make sense. Because we have the whole subordinate thing. So why can't I write in my subs? Doesn't make sense. Okay, let's see real quick. So we've been doing this command right here. Where did my command go? Hold on, let's run this again. I want to run this as root, even though I'm pretty sure it's going to yell at me about writing this as root. Refusing to install rootless Docker as the Docker user. Is there a way to get around this? Because I'm like the root user, but I'm the root user in a container, so it's kind of different. Like, I still want to be able to do this. Like, why can't I do it as root? I want to do it as root. I want to do it with the capabilities that I have. I just don't have all the capabilities in the world. Okay, let's switch over to test. Oops. We already installed it, but I just forgot the command for running it. Oh. What? What? How do I start it, though? I forgot. I forgot how to start it. Tell me how to start. Yeah, I want to start. How do we do this? How do I start? With packages. Usage. With system, we don't got systemd. No systemd for you. Which could be an issue, but we'll deal with that later. To run the daemon directly without systemd, you need to run docker rootless.sh instead of dockerd. Okay. Cool. ls bin, oh, cd that, ls bin dockerd rootless sh. Let's just run it. Okay, well, if you need things set, why don't you set them? I don't remember how to do this. Okay, let's run bash history rep export. Okay, export this thing. Lowercase export. Okay. Oh, I see. I also need path equals this. dockerd rootless. dockerd rootless sh. Okay, so we already see that failed. That failed, as we saw before. But I want to run this, and I want to run it as a root. How do I run this as root? Okay. Okay, we'll do this out of the home test directory, even though we're running it as root now. This script must be executed as a non-privileged user. But I want, this is so sad. I need to execute it as this. Okay, hold on. Cat, home test bin docker rootless sh. Can we just run? Oh boy, it's actually doing some stuff. Like for example, hold on. Maybe we're. I mean, we'll try non-rootless, right? If we start up Docker D, this isn't going to work, right? Yeah, this is. Well, that's not in the world. Container D. No. Okay, wait. I already also said rule number 1 was being broken. Must have. Yeah, how can this possibly be true? Yeah, that's good. The writing process must have cap set UID. Is that the only thing I'm missing? Okay, can I just grant myself cap set UID? Cap sh help. Cap sh switch to test user, but with all capabilities. Who cares? Just give me all the capabilities. Yeah, I want to do this. Give me all the capabilities. So I'll basically be root, but I won't be root. That's fine. Test. No, we don't have test user. That. Okay, and we need. What do we need? We need this. Okay, and we need this. Let's get rid of strace. Well, let's paste again. This one, that strace. Cool. Okay. Now we also need to copy this. Except, oh, we already copied it. Test. Okay. Put me over to the test user. Unable to set capabilities, caps equals all equals I. Why? Just give me the capabilities you can give me. What capabilities can you give me? Just use following command. Okay. Well, we can't give them all. Well, cap sh print. Can I like, instead of, what is EIP? I think I've read this. Can we say like current? Oops. Nope. Oh. What about just all? Nope. It was previously EIP. I've seen EIP in there. This just says EP. What if I just do all equals EP? Okay. Well, let's give ourselves, what capability do we need? Set UID. Cap set UID. Set UID. Cap set UID equals cap set UID. What? Unable to interpret. How do I say that I want cap set UID? Does it just set UID? Okay. Okay, let's try this one. Chone. Okay, how do I give myself a capability? Why is it unable to interpret this? Set priv an actual command? Oh, it is. Okay. Well, let's try that one. But instead of test user, test. Requires group stuff. Okay, well, don't give me groups then. I don't care about groups. Oh boy. Glib. What? We'll just say, hold on, let's go back here. Clear groups. What is this insane stuff? Oh, you've got to be kidding me. Bounding set equals dash cap set UID. Sure, give me all the capabilities. What? That user include Linux capability.h rep cap underscore. Cap sh dash dash print. Okay, this is like absolutely impossible. Like, is this just giving me a bad error? Unknown. Hold for. Can I just have my capabilities? Set priv, give myself set UID. Hold on, someone must have done this before. Like the entire purpose of this command. Okay, yeah, what if I don't say my bounding set? Dash dash bin bash. Oh, there was an all right here also. Okay, what if that's just the default behavior? That is, in fact, does not seem to be the default behavior. Oh, wait, I'm test. ID, cap sh, dash dash print. Oh, but I lost my capability, so that's useless. Inherent capabilities. Okay, here we go. Maybe this is why. Cap set UID. But can I maybe have that capability? How do I gain this capability? Unknown capability, cap set UID. It's definitely called cap set UID. Well, that's not gonna work. Oh, okay. Hold on. Cap sh dash dash print. Nope. We lost it. Okay, hold on though. Let's go back. New chat. Set priv, give me cap set UID and become test user. Okay. Bin bash. Wait, that's not it. Set priv 0 bin bash. That didn't work. How does this command work? Set the real, effective, or both. But I want to like... Can I not like keep my capabilities? Okay. Oh wait, there was like a dash in there. Hold on. I think dash means get rid of. I don't want that. See, that's inherent capabilities. Wait, when did it work? Okay, this did that. If I do this, doesn't know that. Okay, so it does it without the cap. That's the first thing. I want the set UID. Yes, okay, look at this. We got set UID now. Okay, well that took forever. Okay, so here's how we can start up a test user with our capability. And in theory, some of the rules we were violating are happening because of that. So let's go ahead and see if this works now. Copy, paste, copy, paste. It seems to not be thrilled. Operation not permitted. Cap.sh dash dash print. What happens if I do like sudo cap.sh dash dash print? I don't know test's password. I guess test's not a sudo user anyways. What if I do strace cap.sh dash dash print? Do I like lose my capability? No, I still have it in theory. Current. No, how do I make it also my effective? What are ambient? I don't see. I don't know what all these things. I just know they exist, but I don't know what they are. Ambient capabilities. Do I need that too? So like, if I start at bash, D. Why is it when I do bash is trying to read this? It's also very strange. Okay, hold on. Run rootless Docker as the root user. Which sounds insane, but that's what I think I want to do. Let's see here. To run rootless Docker inside of rootful Docker. No, but that's not what I want to do. I want to run it as the root user. Maybe I should Google some more about this error message. Docker drootless. Wait, this. It's just failing. I think it's failing because I don't have capabilities. But how could this work? Even if we assume privileged, how could this work? Because you're never going to... Okay, hold on. We need to Here's what we need to try. We need to try. We'll do this. Move this over there. How does this? Okay, cool. Let's go ahead and do docker run it rm -- privileged Ubuntu 2004 boom bash. Okay. Now we want all of these things. I want to do all of this. Apt updates. There's no sudo command. So that's kind of sad, but we'll deal with that. User add or test user. Install this stuff. Rootless Docker. So we su to test bash. Okay, we don't have curl. Apt install curl. Did I start this container privileged? I did. Okay, good. Curl SSL. Okay, su test that. Okay, we need more stuff, I guess. Copy. Mod probe. What? Skip IP tables. Yeah, let's skip IP tables. We don't want none of that. Su bash. Su test. And then curl it again. Okay. What? I said I don't want this. Oh, it's on the wrong thing. Bash this. That doesn't work. Skip IP tables. Okay. Okay, we have to start it up ourselves. There. This complains about this. Export that nonsense. Do this nonsense. Okay, hold on. It seems like it got further. How could it have possibly gotten further, though? Well, there's no IP executable, but that's fine. Docker ps docker exec it f7 6 bash. Okay. IP link set loop back up. Su test. This. Bash. Docker ps. This. Docker ps. Okay. This. Docker ps. Well, that's not good. Somehow it was able to do what it wanted to do, though. But why? What did it do that allowed it to do it this time? Okay. Kill 9 3004. Docker ps. Oops. ps aux kill 9 30 87. Okay. Apt install IP route 2. Okay, IP command exists. Boom. Okay. Docker su test bash export docker ps. Okay, docker run itrm ubuntu 2004 bash. And guess what? Okay, so we're in a privileged container. We're running docker in docker. The second layer is rootless. Pretty sure. And guess what? Look at this. Yeah, look at this. I'm like in a new container. It's crazy. Okay. That shows you can do it for a privileged container. Let's see groups. Boot the system. Okay, whatever. Can I like actually like app update? Or this apt update. Yeah, this is insane. Okay. So we can do it privileged, as everyone says. You can do it privileged. For some reason you can't do it unprivileged. Like I want to see that system call succeed. strace -f to temp test. Well, that seems strange. Oh, we don't have strace. Apt install strace. Oops. What rule am I violating? And I'm pretty sure I'm violating, like I know what rules I feel like I'm violating. I think I'm violating this rule. But I don't know how a privileged container isn't violating that rule. The writing process, but all of these were rootless. How could this work? Let's see. How does rootless Docker write to this? How does that succeed? Fail invalid argument. Caveats. How does it work? This thing. Okay, yeah, this explains it. Okay, so we have this mapping here. Rootless. So everyone is pointing at 0 and 0 pointing at 1000. 1000 points out of the sub ID. Okay, but no one's explaining this. But this is our error. So, okay, so that one container has only... Okay, hold on. Maybe this is our issue. Okay. Docker ps. Nope. Wait, what's the command? Cat proc self UID map. How big is my UID map? Okay, this map is big. No, this is not my issue. If I how big was what it was trying to do? Less temp test 535 right. So it's trying to use this range, this range, this range. Okay, but what if I look at cat etc sub UID? Yeah, it seems like this is not our issue. So this is saying like, hey, look, you ran this, you only had this much space to work with. It doesn't make any sense. Cat wait. Proc self UID map. Su test sudo su test. This doesn't change somehow or something. Cat proc self UID map. Yeah, we've got this huge range of mappings. Right? This is saying that 0 corresponds to 0, this huge range. This person had an issue where they didn't have a huge range. They had a small range. It makes it impossible to further delegate to a nested container. We've got that. So this is, oh, that's so sad. And that's just that. How do I, what was I doing? Oh, strace, there we go. I want to see this succeed. Well, first things first, cap sh dash print says this is my bounding set. Hold on, let's see. Is there capabilities granted by any of the binaries in bin? View added capabilities of a file. See, I don't know the terminology here. Get cap. Get cap on bin. Oh, what is this? No. CD there, ls bin star. Get cap. No, none of these grant capabilities. Whereas like get cap bin su. Wait, what? Does get cap not do that? Maybe people don't use man get cap. Whatever. Okay. That doesn't seem to be the issue. Okay, and the thing I wanted to run was I was going to do this with strace. Wait, this failed. Failed to set up the mapping. Wait, if I do it without strace, does it not fail? Okay, strace makes it fail. Cool, that makes things fun to debug. Where does this write happen? Right here. So that fails. Why does it fail? Why does it fail with set UID or with strace, but not fail otherwise? Can I like? No, I can't just attach. That's not gonna work. Okay, this is, as we can see, this is very hard to do. To run rootless Docker. run rootless Docker in an unprivileged container. Inside unprivileged. Inside an unprivileged container. Yeah, this is the error we got. Okay, this person seems to have our issue. This is exactly it. Applied even S tracing, brought nothing new. Operation to UID map. Yep, that's us. That's our problem. This is running inside your container. The permission checks would fail accessing the files inside that container too. i.e. check your UID map in your container, not on the host. Okay, don't ask why, just know that I want to do it. Just alternatively, I'll just virtualize. Updates, just virtualize. Full working as wanted. Now provide. Okay, looks like they didn't figure it out. Okay, I need someone to say unprivileged. It's got to be stated. In fact, I need to say unprivileged container. Docker, I think non-root user. Rootless. Can I run rootless? Okay. Supporting running podman containers inside unprivileged Docker container. Yes, okay. This is different, but let's assume this is gonna have the same limitations at a syscall level. Fortunately, yeah. This is possible with UML. Wait, did we already read this one? Like it supports my testing. Okay. UML. I don't know what this UML thing is, but running with fuse overlay. Need to set UID and set group ID to handle setting up a namespace. Podman and Docker is the tighter seccomp control. We can assume no seccomp filter though. Docker seccomp JSON mistakenly blocks all mounts. Okay, but that's not our issue. This is the issue. The UID, group ID, the storage flag, separate, set up within the container. In respect, you won't have. Set UID. We may need a few capabilities that aren't available in an unprivileged. Set UID was. Wait, is set UID not available? How is it even possible that set UID isn't available? Cap sh -- print. Set UID has to be available. Sudo su cap sh -- print. Didn't we already confirm that? Rep set UID. Yeah, we've got cap set UID. I don't know what they're talking about here. Unprivileged containers have set UID. I'll publish a blog on it shortly. Specifically mentions create and destroy containers while running inside an unprivileged container. With automated test and CI environment. Yeah, sure, exactly. How is this possible? Sure, we can do this. This is fine, we'll do that. App armor equals unconfined. Currently have to disable SE in Linux since by default it blocks. Is this the issue? Do we need app armor equals unconfined also? Okay, let's test that. Okay, so we've already seen we can start Docker in a privileged container. Okay, that was privileged. Let's assume we don't care about this stuff though, but we're not going to do any capabilities you just want. We're going to do this. -- security opt -- security opt. Okay. I don't know exactly what app armor is, but maybe this is the issue. Okay, we need let's install this stuff. Apt update. Okay. su test bash this. Forgot curl again. Apt install curl. Skip IP tables equals 1. Okay. This this no, that didn't fix it. Some reason something's missing. Wait, I could have read this with this was a question, not like a wait, this says currently have to disable SE Linux. So this person runs this and can't do stuff. Okay, well, we can't do this. We can't do -- privileged. Isn't this issue specifically about unprivileged? Yeah, it is. Privileged. You can't run a privileged container there. It's simple. I wish there was a way to like see what capabilities are required somehow, like while S tracing, like somehow know why the syscall succeeds. Don't know what this is. Only works here if you add this. Sysbox. What is Sysbox again? Proves locks the container's initial amounts. VMs. A container supercharger. Anything advanced? Well, maybe we need to look into this. Unlike this, does not use VMs, which is good. Nested vert, we have this. This is good. We like to see this. Okay, well, maybe we need to try this thing. This is something we've thought about in the past. Maybe it needs to be explored. Rootless privileged. Wait, what does that mean? Oh, privileged. Yeah, of course. Help us improve Sysbox, a new type of run C. Side on should be doable and not too difficult to implement. Can already Docker plus Sysbox containers can run. Okay. Without requiring. Okay. So maybe Sysbox. What's the downside to Sysbox? Has anyone in the chat used Sysbox before? Probably not. That's okay. But maybe you have. If you have, say something about it. Okay. Sysbox. Okay, how do we run Sysbox? Let's just run it. What's our wait. Let's read about it. There's gotta be, but it says it doesn't use a VM, so that's cool. So it doesn't have its own kernel? No need. Easily choose which containers or pods to run with each, depending on your needs. Okay, these are the problems we solve. I love this. This README is great. Enhancing the isolation. Root in the container maps to an unprivileged user on the host. Okay, cool. Enabling a highly capable root user inside the container without compromising host security. Well, that's awesome. We love to read that. Without insecure privileged containers. Okay, or host. Yeah, it is good. No insecure privileged containers. No host Docker socket mouse. We love that. VM-like environments. Well, you know what? The challenge environment is kind of a VM-like environment. Strong isolation. Okay, I can run this. Running legacy apps inside containers. Okay, whatever that means. Placing. Okay. Multiple isolated compute environments with 2 times the density of VMs. I.e. deploy twice as many VM-like containers as VMs on the same hardware at the same performance. Probably because it just uses less memory, which has to do with not having your own kernel. Partition cloud instances into multiple isolated compute environments without resorting to expensive nested virtualization. True, but that's not an issue for us, but that is kind of cool. Okay, installs easily. This is how we get to use Sysbox. We use Sysbox run C. Okay, whatever this means. Isolation rating. Oh, this is like full-on stuff. Like, okay, hold on. So, standard container. Oh, wait, we do have an OS shim. Wait, what does that mean? What is a light OS shim versus a full OS shim? See, this is super light. It's great. It's just namespaces. As soon as we have an OS shim, that means we got like another kernel running somewhere. Why? Or shim? I don't even, what is an OS shim? Let's see here. So they claim See, look at this. Speed and efficiency. They claim, so obviously this is all like self-reported numbers, but they're saying they're less speed and efficient than just a container, which is sad. Maybe it's worth it, but it is sad. And then they're claiming that like kata is like less efficient, that these people are less fast. What is an OS shim? As shown, enables to run system level workloads seamlessly. What's the need for or OS space or user space OS is like gvisor, therefore alternatives such as kubevert, expensive lore. What do they do? Community edition versus enterprise. Okay, so we're not paying. No. Okay, I don't even know what this is, so we don't get that feature. That's cool. Okay, I don't care about that. Sharing inner container images. Whoa, hold on. Inner container image preloading. Avoid the need to pull inner containers images. I don't really know what that means. Sharing inner cross sysbox. 10 times less storage. How do they measure that? Okay, this might be important, but system containers, not just a micro. How does it work? Like, what's the fundamental thing that they're doing under the covers? User namespaces, partial virtualization of procfs and sysfs, and selective syscall trapping, and more. Sysbox does not use hardware virtualization. Run multiple Sysbox does not use hardware virtualization. Purely OS virtualization. Efficient. Isolation-wise, it's fair to say stronger isolation by virtue of using the Linux user namespace, sure. So it's stronger isolated and lightweight. Oh, I just see, what is this? But weaker isolation than VMs. Okay, well, that's no good. Sysbox is now part of Docker. What does that mean? I don't know what this means now that they're part of Docker. Inner and outer containers. Inside system container. Let's prevent confusion, outer and inner containers. System container. At the host level, it's launched with Docker plus Sysbox. Inner container is an application container created within the outer container, e.g. is created by the Docker. Okay, that's fine, sure. VM-like containers. These people claim that rootless Docker, getting back to our initial problem, Docker cannot run in rootless Docker. But it can run in Sysbox. Who knows why, but that's what they say. Hmm. Hmm. Can we trust these people? Is this gonna like fail? Yeah, they only got 2,000 stars, which is a lot, but is it enough to not come crumbling down? Hmm. Hmm. How does Sysbox work? Hmm. Simply mounting a host directory. Okay. That's an interesting thing, kind of ish. Given host directory mounted, must only be mounted on a single system container at any given time. Image test shared for appropriate error. That's lame. Why? System containers. Doing some breaks. Yeah, that doesn't sound good. Inside a system container, you can deploy privileged Docker containers. Don't want to, but it's okay. In the context of the system container. Oh, okay, there's so many layers of containers. Okay, limitations for the inner Docker. However, some limitations. Inner Docker data root. The inner Docker must store its images at the usual varlib Docker. This directory is known as the Docker data root. While it's possible to configure the inner Docker to store its images at some other location within the system container via the Docker daemons data root option, Sysbox does not currently support this. Why? Inner Docker user namespace remap. The inner Docker must not be configured with user namespace remap to be used on further isolating them. This is useful. Even without the inner Docker, inner containers are already well. This is so many layers deep. I'm sure they're just like emulating some syscalls. That's probably why it's slow, like somewhat slow. Nah, I don't want to watch it. What's Sysbox? Okay, let's zoom out. We want to be able to run challenges that are basically built off of a Docker image so that we can have our user container. Our user container has all the tooling, your persistent home directory, etc. And then suddenly we want to spin up a challenge container within your user environment because challenge authors might want to further customize it. That's kind of dumb because we could just have it where the user container is modified by a challenge author. Well, part of the goal of today's stream was to figure out if this was even possible. It seems to not be possible. It seems to be the consensus. I'm still, of course, not 100% sure because I don't fully understand why it's possible in a privileged container, but not possible in an unprivileged container. We haven't managed to crack that. But lots of people say that it's not possible. Like these Sysbox people say that you cannot run Docker inside of rootless Docker. They just make that assertion. Of course, we haven't gotten to the root of that. Why? Like what syscalls are failing. Well, I mean, we've seen syscalls fail. It's just not clear why those syscalls don't fail in a privileged container. What else? Well, okay, hold on. There's one thing I would be curious to see. If we start up, let's see here. So if I do cap dash sh dash dash prints, well, we already know that that failed. Let's go here. Cap sh dash, well, okay. Start up this thing, cap sh, apt install, apt update, apt update. Apt install apt update, apt install strace. No, that's not what we want. Apt install. See, I'm getting tired now. This is no good. Unshare cap sh. How do I install these things? Apt install unshare cap sh. Tell me what do I need to install? Apt unshare. Oh, we already have unshare. Cap sh. How do I install cap sh? I want to install cap sh on Linux. Please do. This thing. Okay. We can see we got all these things, right? All of them. That's very cool. And then user add test, su test, su test, cap sh dash dash prints. We can see we got the same bounding set, but all of our privileges disappeared. Totally cool. And then if we do unshare run cap sh dash dash prints, guess what? Well, what happened here? The bounding set got bigger. Current equals EP. What does that mean? Cap sh dash dash print. What does mean? Is this? No, we're on 3.5. I don't trust 3.5. 4. Current capability of representing E. P. So what does it mean? It means that the current process has both effective and of none. So it has no capabilities. Hold on. unshare user ban unshare. We want a user, but then we also want to map it. Where's the thing that says map? R. Unshare RU user. Yeah, sure. Cap sh dash dash print. Well, I don't think I understand that. Unshare RU. Cap sh dash dash print. Cap sh dash dash print. Plus EP. Cap sh dash FRU. No. Unshare FRU. Cap sh dash dash print. Founding sub. Sh dash dash print. Not clear at all what's going on here. IPA, nope. Yeah, I don't know why we can't do it. Can I do dash dash? No. Unshare you. Unshare. No. Okay, it's not clear. Why we can't do it? Like, what's the syscall? I mean, it's happening here. Like, cap set UID. The running process must have cap set UID. Is this like out of date? Is it possible this is out of date? User namespace. Oh no, that's not good. That's 2013. That's too old. Sure of it. Kernel. Unless, did it like set namespace or something? namespace. Okay, so in this case, so we've changed things. We have 863 creates 870, but it also created 871. This is failing. Seems unlikely that we have cap set UID, but somehow we're passing that in the other case. Set namespace. Nope. 871. Does a whole bunch of nonsense. Whole bunch of stuff. 71. Still loading in libraries, creating memory, connecting up to this socket thing. More libraries to load. Read in Etsy password. We read that to figure out what we're about to do. We read that to really figure out what we're about to do. Okay. And here we go. We write this. I mean, what if we Docker rootless don't, because so here's the issue. I've done these syscalls before, and I've done it without the second line. Well, okay. How did I succeed there? Well, I did it in a different way. Or otherwise. Right. Eval. Okay. All the following permission requirements must be met. This just like isn't true. I don't understand. How does it say that this is true? This can't be true. Does anyone else talk about this? Because that rule isn't true. Yes. The writing process must have cap set UID. It just hold on, maybe we need to think for a second here. Okay, hold on, maybe it is true. The writing process must have the cap set UID capability in the user namespace of the process. Do we somehow have the capability because we're the same user or something? Like, does the parent somehow have the capability even though it's not in the namespace yet? Like, when, okay, let's read more. When a user namespace is created, it starts out without a mapping. The blah, 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 expose mappings. The UID file exposes the mapping of user IDs from the user namespace of the process PID. Processes that are in different user namespaces will see different values. One-to-one mapping of a range of contiguous user IDs between two user namespaces. When a user namespace is first created, this file is empty. The specification in each line takes the form of 3 numbers delimited by white space, blah, 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 blah. Hmm. Hmm. Okay. Let's just pretend for a second that's true. The writing process must be in the usernames. Why would both these be true if what I'm saying, like, you don't need both rules if what I'm saying is true. Unless there's other ways to get cap set UID. Their namespaces. File must be namespace. This way, programs in the tree could change to any desired. Fortunately, spawning a process in a new user namespace effectively. Something tells me that, okay, where would it make sense for it to fail? On why privileged works and unprivileged doesn't. I don't believe this Etsy file. Etsy, whatever. Cat Etsy sub UID, this nonsense. I don't believe it. That this like has enforcement mechanisms here. Like the kernel is what, reading this thing? The kernel is not reading this thing. There's no rule here that says that the kernel is reading this thing. But a privilege, so probably when we create these users, it's probably something that actually says our mapping to the host. And when we do dash dash privileged, we probably have like a namespace mapping that we can abuse or something. What does dash dash privileged do? It probably does another thing. What else does it do? Dash dash privilege does more things, I think. I want to see everything that dash dash privilege does. What are all of the things that dash dash privileged does? Okay, that's not what we're looking for. What is everything that dash dash privileged does in Docker? In Docker. All the capabilities, C group, wait. But it probably does something else with like this user name mapping thing. Mapping. User. Well, maybe that doesn't make sense. Okay. Okay, turns off both of these things, all capabilities. Dev, host namespace access. Not sure how that happens. Cap add, cap drop. Hold on. How does Etsy sub UID work? Docker remap. Docker rootless, don't add subordinate range. On the host. What? What are these things? Rootless mode does not use binaries with setuid bits or file except for these ones. Okay, here we go. This is why privilege is working, I think. Something about privilege is allowing us to do whatever it is that these things are trying to do. But it says it wants them on the host. Hold on here. Okay, let's run privileged again. Privileged. Okay, what are all these things we need? We need Control C, this, apt updates, apt get install UID map. Okay. So we are install. Okay, we knew we were installing UID map. Which UID map? Okay, well, we installed UID map. Doesn't seem like, oh, this. Is this the which? This. Okay, here we go. LSAL user bin new. Okay, this thing is set UID. And what do we think it's gonna do? We think it's gonna somehow access the host or something insane. Like, I bet it is. But it accesses the host through privileged. What is new? How does the new UID map program work? Yeah, this doesn't say anything else about how stuff actually works. We just know, for whatever reason, these programs need to exist. Version of that uses shadow utils. Yeah. Look at these things. Okay. Well, we don't have that, but we'll take their word for it, right? It does this. So when I was S-tracing before, even in a privileged container, it didn't work. It's probably because when I S-trace, we're not getting our capabilities. Okay. Well, let's just run this program. What is this program? Somehow user bin new UID map. Well, yeah. Can someone tell me how this program works? This is kernel. This is owned by, it's not mapped in, appears to belong to the user. Any item from outside of the user namespace that is owned by a... Oh, yeah, this stuff. Nobody. Yeah. The nobody stuff. Cat proc. That thing. We've seen that before, even in unprivileged containers, it's the same thing. Automatically allocates. Set up the user namespace. See the mappings by examining proc self UID map. Take the word for it. Any item from outside of the user namespace. No, but like, we are specifically interested in this program. Is this doing something crazy? What does do? Color is the owner of the process. So it sets proc PID UID map based on its command line arguments and the UIDs allowed. Sub-UID delegation can either be managed via etc sub-UID or, okay, so one of these two things. To the PID argument expects 3 sets of integers. The beginning of the range of UIDs inside the user namespace, beginning of the range of UIDs outside of the user namespace, the length. This verifies that the color is the owner of the process indicated by PID, and that for each of the above sets, each of the UIDs in the range, lower blah, 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 is allowed. Okay, but hold on. We saw this in our strace, new UID map. New UID map. Okay, so it's searching for this program. Eventually it must find it. Yeah, look at this. It found it, right? User bin new UID map 863. And then it's mapping some, probably setting up dev null to be, well, who knows? 863. It spins off a child. Okay, is it 863 that does the write? Or who? Someone call exec v. Yes. 871. 871 my writer. Right. 871 is my writer. Okay, so this program does that. So that's why strace breaks it in the privileged container. Okay, and this also, okay, finally this makes sense. This, where is it? We lost it. All right, this right here happens. This is true. This does pass. This passed because we have a cap set UID program. It's on the file permissions. Okay, so this is checked. This is good. This is totally fine because at least when we don't strace, we need, maybe we can find a way to run strace and then detach from that so that we can get our suidness or whatever. But either way, this works. This is totally cool. We've got a program that adds these capabilities. In fact, if I do get cap, which new UID map or something, get cap user bin new UID map. Wait, what? Maybe it's just set UID. I don't know. Pretty sure this is granting permissions though, so we're fine. Okay, the writing process. So now this process, which we've exec'd, must be either in the user namespace, it's not, or be in the parent user namespace. It is. Okay, so only me or the parent can do it. The mapped user IDs must in turn have a mapping in the parent user namespace. Mapped user IDs mapping in the parent user. It does. It has to do with that, right? When we do cat proc self UID map, right? It's in the namespace. This is our parent namespace that we're in currently. It has a massive range. We get ready to map just a subsection of it into the user namespace. It's good to go. If updating UID map to create a mapping that maps UID 0 in the parent namespace, then one of the following must be true. We aren't doing that, so the fact that this is about to fail, it's totally fine. Cap, but I am curious, do I have this? Because maybe I'm wrong about this. Grep fcap. Either way, in theory, when we do our set UID-ness, right, it should be good. Unless it drops that capability in that other thing, which it might. In fact, it probably does. But this maps UID 0 in the parent namespace. We're not doing that though. That's, if we look at where we failed, less new UID map, right. This fails, but guess what? So 0, hold on, let's read the format. The range starting at user ID 0 in this namespace. Well, hold on. 0 in this namespace? It maps to a range starting at 0 in... Hold on. What's the format? The start of the range of the user IDs in the user namespace of the process PID. Start of the range. Hold on. There's a place I can check into this because I've done stuff like this before. This might be backwards. Intro, intercepting communication, run, get or UID map. So I'm 0 on the inside and something else on the outside. But that's sketchy. Hold on. 0 on the inside, something else on the outside. I think we're fine. That was done from the inside perspective. Hold on. So each line specifies a one-to-one mapping. Okay. What's the format? I'm pretty sure it's 0 on the inside, so we don't apply to that rule. Description in the following paragraphs explains the details. Each inch from the user namespace of the process PID to the user namespace of the process that opened UID map. The qualification to the one that opened the UID map. Yeah. So 0 of that process's namespace maps to 1001 of the person that opened it. Okay, so that lines up where we should be good. In other words, processes that are in different user namespaces will potentially see different value. Okay, this is like sibling namespaces or something. But there's an exception. Wait, where see a qualification to this point below. I remember there was something about if you do proc self, right? Yeah, whatever. Or field 2 in the same user namespace. Sure, field 2 is the start The range in the okay, so if you do it within your, if it's both namespaces are the same, then the second one is actually just the parent. That's what that is. But either way, moral of the story is we're passing the rules because A, we don't do UID 0 in, and even if we did, this is probably fine, but maybe not. But to create a mapping that maps in the, yeah, we're not doing this. So we're fine because of that. Okay, and then one of these two has to be true. Either the writing process has this capability in the parent user namespace. Well, how is this rule different than this rule? Either the writing process has the cap in the user namespace of the process PID. Okay, wait a second. I don't know that this is true anymore. I changed my mind on this being true. We're going to come back to this in a second. This is true, though. Either the writing process has the cap set UID capability in the parent user namespace. Because we do, because we're a set UID program, right? The writing process in the parent user namespace, which I think we do, right? Because it's a set UID program, we're running it from the parent in the parent user namespace. Unless it means my parent's parent. Either the right in the parent is the process. Oh, maybe this is an issue. Hold on. This might be talking about the grandparent or something. The data written to UID map must consist of a single line. Okay. Well, I'm guessing that we're either breaking this one or this one. What's the difference between these two? The writing process must have of the process PID. This is italicized, yeah. But do we? The writing process must have. How could we possibly have this? I don't see how we have this. Where's the parent? Who is the parent? Can we define what the parent is? User namespaces can be, that is each user namespace except the initial has a parent user namespace. Parent namespace, and it creates the parent user namespace is the user namespace of the process that creates the user namespace via a call to unshare or clone with this flag. Okay, you can go 32 deep. That's fine. If you're always in one of them. A single-threaded process can join another user namespace with set namespace if it has the cap sysadmin in that namespace. What if this is the issue? Is someone calling set namespace or something? How do you figure out your own capabilities? Syscall to determine process capabilities. Cap gets. Hold on, maybe we can find the source code of this. Make sure it doesn't do anything weird. Doesn't seem like it changes its namespace or something weird. But I wonder if this capsys_admin is the problem. Let's try it. And instead of privileged, let's just do unconfined cap add sysadmin. sh print grep sysadmin. It's not going to work. But let's go ahead and do this. And this apt update. So what are we allowed to do if we have sysadmin? A single can join sysadmin. Allows within the user namespace that owns a process. Created with just if clone resource governed. It would be weird if this works, but let's see. Install curl. Test this. Skip IP tables equals 1. Okay. Got that. We got that. Do we need that other one? Hopefully not. That. Okay, this succeeded. So adding capsys_admin did fix it. Okay. Why does capsys_admin fix this? We write either of the strings allow or deny. Let's see. Can we drop a capability? Drop capability from bounding set. Drop capsys_admin from bounding set. No, but I want to do it Linux command line interface. Cap sh. Docker ps, docker exec it 3d4 bash. Apt install. How do we install cap sh? Cap sh install apt. Yeah, I want to install it. Yeah, no. Install it with apt. See, GPT gets confused sometimes. Lib that one. Okay. Ox kill 2965. Okay. grep sysadmin. Okay, so we currently have cap sysadmin. We do su bash or su test. And then this. Okay, that. And then drop this capability. Oh, but we got to do this as root. Bin bash grep cap sh print grep sysadmin. Sysadmin's gone now. And then if we do su test, copy all of this. So now we're basically shortcutting down to the step where we don't have sysadmin. And guess what? We can't write. Okay, so sysadmin is doing something. Unfortunately, this documentation doesn't seem to tell us why we need sysadmin. What does cap sysadmin grants? Do UID write to UID map. So somehow cap sysadmin is doing something related to us writing to this. Yeah, this right here. For when I add, instead of, it fails. So the in-kernel check for proc self UID map requires both capset-UID and capsysadmin. There's also check in map right. Wouldn't need. You passed a file descriptor from the containers user namespace, but that would no longer easily. It's writing to a process's UID map. I don't fully understand that, but okay. Seems. I'm not sure, but the CPR for this. Okay, it says if EUID does not equal owner of the user namespace, the kernel requires capsysadmin. That's why I want to run as UID 0. Changing any namespace ID mappings should require privileges. What does that mean? Doesn't change your ID within the namespace. It reconfigures the namespace. Doesn't change. Unprivileged programs should not be able to write to these files. this definitely has a patch where, okay, view file. This is adjusting namespace. This says you need capsys_admin. Is this still true in master? Not that we're running master. Yep, it is. When did this change happen? 2013. That's a long time ago. PR work. Wait, what the? Set. What's the program? New UID map. New UID map. Help. They're like version info. Nope. How did they get around this? If we have the capability, we do this. If have sys capability. Could not PR control. I don't get it, but other people like this thing. So that it does not require capsys_admin. Does not set UID bit on the BusyBox version of BingSU. Read lock. I don't know what that means. Shadow UID map. Can we apt install that? Apt install shadow UID map. Apt shadow UID map. Apt UID map. This is 481. GitHub UID map. New UID map. This. Support passing PID as FD. What is this insanity? Currently take an integer PID as the first argument, determining the process ID on which to act. Also, except also FDN, where n must be an open file. This way, if you blah 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 and PID 99 dies and a new process happens to take PID 99, we'll change the mapping for the process. Okay, yeah, I don't really care about this. Capsys_admin. Okay, so that analysis is partially wrong. For what it's worth, my first one was 2. What actually fails is the capsysadmin in the target user namespace. In the first check with file ns capable fails in the setuid case. Here's my full analysis. So this is setuid. Only caps that are kept are cap setuid and cap set group ID. You first hit this, it calls into cap capable and hits this loop. Do we have the necessary capabilities? Parent. First check fails and falls through the end of the loop and retrieves the parent user namespace. Checks whether caps. First check falls through the end and retrieves the parent user namespace. Checks whether capsysadmin is available there, which it isn't. Set UID and 2. We just do cap set UID pass, thus pass. Now this hits new ID map permitted and NS capable, which is passed since cap set UID is available in the parent user namespace. Now the right hand side of the conjunct is hit and cap capable loop is entered again. This passes. It's available in the hence you can, okay, what the heck? So it's saying it's set UID. So in the first case, it's set UID. In the second case, has cap set UID as FS caps. So it's file system FS caps versus just being fully set UID, I think. Okay. True, this is my issue. These people are talking about making it set cap instead of set UID. The downside is called as someone other than the creator of the user namespace, it will fail. That's fine. Already changing the UID. Should be as simple as absolutely possible because it's designed to be a it should have no bezel, no. For making new UID map, use file capabilities to gain set UID to gain set group ID. Everything appears. Okay, yeah. These people are talking about installing with file capability, but it doesn't seem like that's how my program is installed. Always run with a minimal set of capabilities. As the file capabilities do not work well with user namespaces for older kernels. Okay. Where do you not have capsysadmin, but have capsetuid? Well, in Docker. How, so now? We're talking about a case where you are in a user namespace, run Docker in there, and now want to run, yeah, of course. And okay, maybe we should just change the program. So that this is true. And git clone this thing, git check out this thing. Okay. What is this thing? Standalone daemonless unprivileged Docker file and OCI compatible container image builder. What? Standalone daemonless unprivileged Docker file and OCI compatible container image builder. I have no idea what that means. One. Okay. What version am I on? 1481. 1481. 1481. Okay, whatever. Let's go ahead and let's change this. Which new UID map? Which new UID map? Cap sh minus s plus al user bin new UID map UID or chmod u minus s user bin new UID map, and I wanted to add set UID fcap to file. Do I have setcap? I do. To a file, run the following command. Okay. User bin new UID map. Get cap user bin new UID map. LSAL user bin new UID map. Cool. Sudo su test bash this stuff. Okay, this means we passed it. This means now we just have the group ID map messed up. Okay, so the group ID is messed up because guess what? It's the same thing. LSAL user bin new group ID map. So we do chmod u-s new group ID map. So we got rid of the set UID-ness and user mod or cap set cap new group ID map. Then su test bash, paste all that in. Oh, we gave it the wrong thing. How do we remove that capability? Yeah, whatever. We'll just add that one also. Set group ID su test bash, paste in a bunch of stuff. Boom! We are running. We're running Docker. Okay, well, not exactly. tsaux or apt install IP route 2. Yep. Okay. We need to kill 93156. Run it again. Open. Well, we got close. The host root file system is mounted as this. Failed to mount sysfs. Open. No such file or directory. Error executing. Okay. Can we just like not have networking? Who cares? We don't need networking. Well, actually, we're going to need networking. Okay. Does anyone talk about this issue? Why do they have to relax that comp? Yes, aux. Kill 9 this. IPA. Ping. Curl. Google.com. Internet works. Executing this. IP tontap add. Is it doing this in the same namespace? Or is it doing it in a nested one? Oh, is it because we're missing tontap? What is this? LSAL, this thing. So we're missing ton flag. Is this actually the open that's failing? It's not clear. Well, we failed to mount sysfs. Well, that's probably not great. Probably need to not fail to mount sysfs. Operation not permitted. Okay. All these people keep saying this. Why do they keep saying this? Doesn't work. Okay. Fail to mount sysfs. Well, looks like other people got close to where I got. What? Okay. Ultimate on-prem customer. It's looking for this functionality. Wow, it looks like there's people that really want this. Is everyone just gonna say you can't do it? Is that really what's gonna happen? Ding. Can we just disable networking? Docker rootless disable networking. Let's just disable networking. Just don't want networking. I mean, I do, but can we really start by saying no networking? Wonder what IP commands are being run. Is this actually just the command that's running? Yeah, it is. Strace. Okay. App install strace. If I devnet ton, lsal devnet ton. Is this like scary? What is devnet ton? If I just give you devnet ton, are you gonna work? What is devnet ton? Well, they want devnet ton. Does a privileged container have devnet ton? Yeah, I think it does because privileged containers get devices also. Privileged Ubuntu 2004 bash plus al devnet ton. Look at this. We got devnet ton. Well, we already mounted dev kvm. Can we mount in devnet ton? Is this scary? What does this do? User. Is devnet ton dangerous? Usable by those users. Well, devnet ton. There is no harm in allowing the device to be accessible by non-root users. Since capnet admin is required for creating network devices or for connecting to network devices which aren't owned by... Okay, I think I can just give you capnet ton then. They say it's not dangerous. Adding dev net ton to Docker container. Okay, people have VPN Docker containers. They like devnet ton. Docker transmission of VPN. DevNet ton dangerous. No one's telling me if it's dangerous. Can I run make node? Probably not. Yeah. Oops. ls devnet. Oh, makedir devnet. Makedir devnet. Well, I got a devnet ton now. I didn't even have to mount it in. Sketchy. Bash. Su test bash. Is this the right devnet ton? Yes, aux. Nope. Yes, aux. Kill 93340. Probably we lose. Oh. Permission denied. chmod 600 or 6. What do we want to give it? 666. Run devnet ton 666. Dev net ton. You test bash. Something's happening. Someone's not thrilled about this, but it does open. Okay, what does Docker say? Oh, what do we have here? This might mean it's possible. Okay, let's see here. You test bash docker ps. Do all of this. There's another thing I need. Docker ps. Oh, Docker run it rm ubuntu 2004 bash. Well, we got the daemon running, but we cannot create a container because we cannot mount. Error mounting proc. So the limitation so far is mounting stuff. Unfortunately, I have to end this stream soon because it is getting late. Oh, also that make node probably doesn't work. I probably need the volume mounted in. That's probably because I was initially in a privileged container. Unmount Docker. Mount syscall. Mount syscall. Need capsys admin to mount file systems. Well, that sucks. But do I? Because hold on, in my user namespace, I've got capsys admin. I think Unshare has an example of this. Unshare. Okay. PID fork mount proc. And user. Skip the mount proc. That works. That does not work. Mount proc. Why can't I mount proc? Wait for... These ones are chill. These ones, not chill. Mount proc in user namespace. Oh, do I also need a mount namespace? Mount proc. I think we also need a mount namespace. That does not seem to help. This rec priv. What if we do -r? Why can't I mount proc? Mount syscall. user namespace. What's the syscall it's failing? Okay. A bind, so we're doing bind. No, we're not doing bind. msrect. Getting eperm. eperm. The ms read only. Am I in a PID namespace? Yeah. An ms read only. An existing, but the mount is locked. The mount is locked. Okay, something tells me I got some mount. How to see if mounts are locked? Okay, cat rock self mount info. Oh boy. grep lock. Lock. I don't see lock. Where is my lock? I don't see locked. What other option? But the mount is locked, or just does not have privileges. Okay. Lock. Mounts that come as a single unit from a more privileged mount namespace are locked together and may not be separated in a less privileged mount namespace. New brings across all the mounts from the original. Mounts the property. Means the mounts are locked. It should be not possible to unmount. Mount. Okay, well, what if that's the issue? Hold on. Proc. Well, I think it is. Attempt to unmount the mount fails us. It's a little confusing. It's possible to stack and unstack a mount on top of one. Okay, so that's us. We should be able to do that. Okay, so we can definitely do that. Definitely mount stuff. I'm just gonna Okay, certain things can't be changed. Mount. Okay, what if we mount this? Let's not do this. Dash ls make dir temp proc mount proc to temp proc cat proc self mount info grep lock. No one's locked. Why can't I mount over proc? Only root can do that. What do you mean only root can do that? Why is that? All right, I'm going to end the stream here. Thank you all for attending. For those that did, it was a very long stream. Probably in a future stream, we'll do something less investigative, less super technical, less staring at things, figuring out exactly why they work. This is probably one of the most complicated things that we're currently working on with pwn.college. So probably we'll work on simpler things in a future stream, but this needs to be done soon. So you know what? Figured first stream, let's just go all in on a complicated thing. Thank you for watching, and that is all.